Hello, we are group 10 and we're going to be solving a chemical process problem. We're going to start off by reading our problem, which is the process involves a 200 mole per minute feed containing 40% ethanol and 60% water. A maximum of 120 moles per minute of this feed enters the separator, with the remaining 80 moles per minute bypassing the unit. The separator produces pure ethanol at the rate of 2 kilograms per minute and an intermediate waste, which then mixes with the bypass stream to form the final waste product. So our problem statement, which is what we need to find, is we need to calculate the molar flow rate and the molar composition of the final waste stream leaving the separation unit. And for that, we need to have our knowns, which is what we know. So we know that the feed is 200 moles per minute and that it contains 40% ethanol and 60% water. We also know that the separator feed maximum is 120 moles per minute and that produces a bypass stream of 80 moles per minute, have the same composition, and that our product is 2 kilograms per minute of pure ethanol. Now we also have our molecular weights. So our molecular weight for ethanol is 46.07 grams per mole, and our molecular weight for water is 18.02 grams per mole. And for our unknowns, we have waste molar flow and waste composition, which is what we need to find to solve the problem. The problem, which is the efficient separation of ethanol from water, is critical in biofuel production. So that is its real-world importance.
Okay, we're going to be moving on to step 3 of the engineering method. We're going to be selecting a principle/theory to be working with it in this problem. One is going to be the law of conservation of mass, and then there's going to be the steady state system. Step 4. This is where we make necessary assumptions. We're going to be describing off with the steady state, meaning there's going to be no reactions affecting this system, and there's going to be no losses coming out of the system. The stream composition is the same as the feed, and another two unknowns we're going to be describing here is going to be the pressure and the temperature. For the molecular weights, they're going to remain constant. For ethanol, they're going to be 46.07, and water, it's going to be 1802.
Is to find the molar flow rate and the molar composition of the final waste stream. So what we know, like I said, total feed is 200 moles per minute, 40% ethanol, 60% water. This translates to 80% mole over a minute and 120% mole over a minute. So as given right here. We also know that the product is pure ethanol, and the waste stream contains both ethanol and water, and we're assuming that there's a steady state in the reactions. What we're trying to solve for, so our unknowns, are the waste flow rate and the waste composition of ethanol and water. So step 1 is converting the product mass flow to molar flow. So we can do this right here, the state. So again, we're finding molar flow, one of the unknowns. We do this by dividing 2,000 grams per minute over 46.07 grams per mole. So this gives us a product mass of 43.412 mole per minute of ethanol. That means the separator pulls 43.4 moles per minute of pure ethanol and no water. So now we find the ethanol balance. That's, excuse me, we have the product mass minus molar flow. So that's, in order to find the product mass, one of the other unknowns, we do 80 minus 43.412, which is what we previously found. And that gives us a product mass of ethanol of 36.58 moles over a minute. And for water, the product for ethanol, so all the water exits in waste. So furthermore, for waste flow, we add our product mass of ethanol to 120, and the waste flow of that is 156.58 moles over a minute. To find waste composition, we do the waste over the flow. So for ethanol, it'd be 0.2337, and since the waste composition of ethanol and water equal to total 1, to find the waste composition of water, we simply subtract the waste composition of ethanol from 1. That gives us 0.7663.
Simpler, easier way. So on the left side,
so
we're going to have an
finally, our waste flow is 156.6 moles over a minute. Ethanol waste composition is 23.4%, and the water waste composition is 76.6%. So now, in order to verify and check, we know that our feed ethanol is 80 moles per minute and water is 120 moles per minute. That adds up to a total of 200 moles per minute, which was a given. So our result is the product of ethanol is 43.4 and the water is 0.
Which comes out, two products
and the waste
come out of
is 36.6 moles per minute. Ethanol 120 moles per minute. Water. If we add this together, it's 156.6 moles per minute, which we had previously found. So another thing we can do double check is add up our waste composition. So the waste composition of ethanol and water together add up to 1, which checks out. And the feed was 40% ethanol. Waste is 23.4%. So this also checks out because it's pure ethanol out as a product from the stream. So the remaining stream will be mostly watery. So leaving the 76.6% of water.
Also going to contain ethanol and water, but this time it's going to be 40% of ethanol and 60% of water. So this makes it easier to elaborate here. Here it is.